ABCD is a parallelogram. BE is perpendicular to AC, and DF is perpendicular to AC. A, prove that triangle FDC is congruent to triangle EBA. And B, prove that EBFD is a parallelogram. Let's start with part A. Prove that triangle FDC is congruent to triangle EBA. On our diagram, let's mark triangle FDC in purple and triangle EBA in green. The question tells us that BE is perpendicular to AC. Angle E2 over here sits inside triangle EBA where these two sides meet. If two lines are perpendicular, then there is a 90-degree angle between them. So let's draw a red 90-degree angle in for E2. The question also tells us that DF is perpendicular to AC. Angle F2 over here sits inside triangle FDC where these two lines meet. So this is also a 90-degree angle. So let's mark it in red. Now we can make the statement that angle F2 is equal to angle E2, and both of these are equal to 90 degrees. We know this because this has been given to us in the question. We need more information to prove that triangle FDC is congruent to triangle EBA. So what else do we know? The question tells us that ABCD is a parallelogram, and we know that in a parallelogram, both pairs of opposite sides are equal. This means that DA is the same length as CB. So let's put a small blue line on these two sides to show that they are equal. We also know that DC is the same length as BA. So let's put two small blue lines on these two sides. Now DC sits on triangle FDC and BA sits on triangle EBA. So now we have a pair of equal sides. So we can say that DC is equal to BA because the opposite sides of parallelogram ABCD are equal in length. We don't know any more about the lengths of the sides of these triangles, but we do know that parallel lines show us angle relationships. We know that opposite sides of a parallelogram are parallel. This means that DA is parallel to CB. So let's put a small blue arrow on DA and a small blue arrow on CB. We also know that AB is parallel to CD. So we can put two small arrows on these two sides to show that they are parallel as well. Now we only have one transversal line, the diagonal AC. So let's make it blue. AC touches both sets of parallel lines. So we can look at different Z shapes, but we need to prove that two corresponding angles inside our triangles are equal. So we need to consider angles next to the transversal line that also sit inside our triangles. Angle A2 sits next to the transversal line inside triangle EBA. So let's make this angle black. Angle C1 also sits next to the transversal line, but this angle sits inside triangle FDC. So let's mark it in black as well. These are alternative angles, so we can now see that angle A2 will be equal to angle C1 because they are alternative angles. The reason why they are alternative angles is because AB is parallel to CD, and we know that this is true because the opposite sides of parallelogram ABCD are parallel. Now in our triangles, we have two pairs of corresponding angles and one pair of corresponding sides. So as our answer, we can say triangle FDC is congruent to triangle EBA because of AAS for angle, angle, side. Prove EBFD is a parallelogram. Let's make EBFD blue. In part A, we prove that triangle FDC is congruent to triangle EBA. And we know that if two triangles are congruent, then their corresponding sides are equal in length. EB, a side of triangle EBA, lies on EBFD. So let's put a small green line on EB. We want to prove that EB is the same length as FD. FD lies in EBFD, but is also a corresponding side in triangle FDC, which means that FD is equal to EB. So let's put a small green line on FD as well. Now we can make a note and we can say that EB is equal to FD. And our reason, because triangle FDC is congruent to triangle EBA. We proved this in part A. So we can just say proven above. In part A, we also found that angle E1 and angle F1 are each 90 degrees. So let's mark these angles on our diagram in red. We know that we can use parallel lines to find angle relationships, but we can also use angle relationships to find parallel lines. We know that EB is the same length as FD, but let's see if we can use these angles to prove that EB is also parallel to FD. Line FE touches both DF and EB, so this is our transversal line. Let's make it purple. Now angle E1 and angle F1 sit inside the Z shape. So these are alternative angles, which we already know are equal. So now we can say that angle E1 is equal to angle F1. We know this because this has been given to us in the question. Angle E1 and angle F1 are alternative angles, and we know that these angles are equal, which means that FD must be parallel to BE. And as our reason, we say because alternative angles are equal. Now we know that not only is EB equal to FD, but these sides are parallel as well. So we have now proven that EBFD is a parallelogram because one pair of opposite sides are equal and parallel.